And welcome to Cisco Straight Talk. I'm Sean Henry, and our presenter today is Matt Hilliker. Today's 20-minute session is on elements of Cisco iWAN. The session will not include Q&A, but you may send questions, feedback, or request a deeper dive through your account management team or by sending an email to straighttalkqa@ciscomtechnologies.com, which you see on the screen. So without further ado, I'm going to go ahead and turn this over to Matt.
Thanks, Sean. Good morning, everyone. Like Sean mentioned, we've got a lot to talk about today, so let's go ahead and get into it. So the modern enterprise will have a bunch of challenges when it comes to their network, and the WAN is no exception. So the typical enterprise will have some sort of WAN redundancy at their data centers, core offices, and branch offices. Now, there are several design options available, usually involving a mix of private connections such as MPLS and public circuits, which are typically commoditized internet links. Now, while redundancy is great and absolutely needed in the modern enterprise, it does present some added complexity and its own set of potential issues. And there's also some valid concerns that involving public circuits often comes with performance and/or security compromises. Now, one of these issues is inefficient use of these circuits themselves. By default, the flow of traffic across the WAN is going to be determined by the routing scheme currently in place. Well, that combined with a lack of visibility or being unaware of application data load can actually cause an imbalance of traffic between your connections. One circuit might be used much more than another. That's obviously inefficient and not very cost effective. You want to be using that bandwidth. You're paying for it. So use it in an efficient manner. Now, another issue is visibility. A lack of visibility is not unique to a dual WAN topology, but the pain can be felt to a greater degree in that type of environment. Now, without examining your routers with show commands from the command line, you often don't know which path a particular data flow is taking. And any experienced network admin or engineer will tell you visibility is the key to lowering your mean time to resolution when issues are occurring. Now, another issue is that most times you're going to be at the mercy of your provider as it relates to performance metrics. That, combined with the routing decisions we just talked about, can create a situation where a particular type of traffic is not being routed over the best connection for it. A perfect example of this is voice and video traffic. That type of traffic is sensitive to delay and packet loss. It's also very difficult to react to and detect an issue where performance is degraded across a carrier's network. So resolving these issues manually can require significant effort, and any solution put in place will generally not scale well across many sites. So this is where Cisco's Intelligent WAN comes into play. Now, the iWAN umbrella has several products within it, but today we'll be talking about a few that are designed to help address the common issues we've just discussed. These technologies are DMVPN, that stands for Dynamic Multipoint Virtual Private Network, Performance Routing version 3, and Live Action. Now, I'll preface this by saying that if you've ever sat through a 100-slide Cisco presentation about any of these technologies, you'll understand that we've tried to condense this for you as best as possible. Some of these technologies are relatively complex, but this presentation should serve as a nice overview that we can expand on later. So the first technology we'll talk about is DMVPN. Nowadays, many organizations are turning toward commoditized internet connections to serve as one of their WAN paths. One driver for that type of hybrid architecture is for direct access to cloud applications. Perfect example of that is Salesforce and Office 365. Another reason is that a lot of firms would like to be able to save on MPLS costs without negatively impacting productivity. DMVPN is a great way to leverage common internet connections and provide the redundancy organizations require, so you'll be reducing costs while still providing secure access. Now, most of you are probably already aware that using tunnels is a good way to connect two sites together in a secure way. On each end, you configure the router or firewall with GRE, IPsec, your routing scheme, and you're pretty much on your way. However, Anyone that has configured that will tell you that the process becomes very labor intensive and does not really scale well when you're talking about more than a few sites. And that's especially true if you're trying to create a full mesh network. Well, DMVPN is designed to address those challenges by creating a true hub and spoke topology with greatly reduced configuration. So with this type of configuration, your hub router is typically at a core site or a data center. And once you have the DMVPN configuration applied to that device, there's really not much need to alter it further. Now that advantage is what makes DMVPN truly dynamic. And what I mean by that is that the hub site does not really need to know about the branches as far as a static configuration standpoint goes. Your spoke configuration is largely cookie cutter, so adding new branches to your DMVPN domain is typically quick and easy. So the key takeaway about DMVPN is that you can provide secure and scalable connectivity for your enterprise over any transport technology. Next technology we'll be talking about is performance routing, or PFR version 3. Now everyone knows that information technology is an undeniable part of our lives, both at work and at home. Work especially, users demand solid performance from the applications and services they use, whether they be internal or external. Now because of this, a new paradigm has taken hold in the modern enterprise that slow is the new down. These applications and services must be highly available, and oftentimes architects look to the network infrastructure to provide that resiliency. And this is where Cisco performance routing comes in. PFR is a technology that monitors network performance and routes application traffic based on performance policies that you configure. You can think of it as an additional layer of intelligence applied on top of your existing routing technology. Now, we all know that there are several routing protocols to choose from. Each one has its own advantages and disadvantages. Well, in general, these protocols only know two states, up or down, or you can also think of it as reachable or not reachable. These protocols to performance-related metrics such as latency, jitter, or packet loss. Well, PFR solves that issue for you by using the WAN links you have to maintain a good level of performance. So we have some illustrations here to help illustrate how PFR operates from a high level. Here we have a typical setup for a modern enterprise WAN. Each site is dual homed with two WAN connections using separate providers, and it really doesn't matter what these connections are. They could be internet-based, MPLS, VPLS, etc. Now, one of the great features of PFR version 3 compared to version 2 is that the policies are configured at the headquarters or the data center router, and once you register the branch routers to the PFR domain, those policies are downloaded automatically so that you don't have to configure them on every branch. That really simplifies the management aspect and keeps it very scalable. One of the first steps in a PFR configuration is to define your traffic classes. Now these are typically based on DSCP markings, but they can be classified using other methods as well. By defining the traffic classes, you're sorting out what the critical and non-critical traffic is. And that's really important because PFR treats the two a little differently. Critical traffic, such as voice and video, will be kept on connections that tend to be more reliable. It's important to keep traffic, like voice and video, that is sensitive to delay and packet loss on links that have SLAs and honor quality of service. Your MPLS connections are going to be a great example of that. In a performance routing topology, a combination of NetFlow and smart probing is used to continuously assess WAN health. So if an issue occurs, such as congestion or packet loss, and it is outside of your configured thresholds, then this would be known as an out-of-policy condition. If that were to happen, the critical traffic would then be automatically migrated to the backup path. And the way PFR does this is through a mechanism that is very similar to policy-based routing. It essentially overrides the normal routing decision that would be made based off the performance metrics. Non-critical traffic will be load balanced across connections based on link utilization. What that traffic is will be determined by the policies you set. It's going to be different in every organization. Some examples might be email, file sharing protocols, things like that. And you'd be able to configure alerting for these types of events as well. Now, the important point here is that at no time will the critical traffic be endangered by this load balancing mechanism. It's very important that we protect that voice and video traffic. It's going to be very intolerant to delay or packet loss of any kind. Now that I've shown you how PFR manages your traffic, you can see how it can be used to remedy some of the issues we discussed previously, especially as it relates to traffic imbalances and performance degradation within a carrier network. So the next technology we'll be talking about is live action. So live action is actually a third-party tool for visualizing network performance data. Now, Cisco and Live Action have partnered up to provide you an iWAN management platform. It provides real-time application and QoS visibility. You're able to visualize traffic flows based on DSCP value, and this allows you to validate your quality of service configurations and look for congestion or policy drops. Using live action, you can also apply quality of service configuration to routers using best practice templates, or you can create them from scratch. So like I just mentioned, with live action, you can visualize a live traffic flow, and that includes PFR path control. You're able to see exactly where your traffic is going in real time. This is obviously much easier than having to decipher complicated CLI output from your routers. The great thing about live action is that it's not just for the WAN. It will actually show you the traffic path throughout your entire network. We're just showing it in the scope of WAN right now, but it will show you the LAN side segments as well. Live action will also give you a visual representation of WAN health. So if one of your paths is experiencing packet loss, you'll be able to see that. So if an out-of-policy condition were to occur, such as packet loss, PFR in that instance will make a path change, and live action can render the end-to-end path changes. Now, I should mention here that live action is mutually exclusive from PFR, but if you combine the two technologies, it really creates a powerful combination. And DMVPN can be folded into that as well. Lastly, you can use live action to apply best practice quality of service templates to your routers, or you can configure a QoS policy from scratch. You'll then be given a nice visual representation of how the bandwidth of that particular interface will be allocated. Now, even experienced network engineers can attest that configuring a quality of service configuration on a Cisco router can be a little daunting. Well, with a tool like Live Action, you get a nice visual feel for how your traffic is being distributed across a link, and it makes it easy to modify without having to go into the complicated CLI interface. So we've given you a nice overview of a few of these intelligent WAN technologies, and what I'd leave you with is to ask yourself some of these questions. Do you know which path your traffic is taking at any given time if you have a dual WAN topology? Are you experiencing a lot of churn within your WAN, a lot of routing changes, things like that? Do you have a solid handle on your QoS configuration? Do you have QoS applied? So if you'd like to have a deeper discussion about any of these questions or the technologies we've discussed today, please reach out to us. We'd like to help you out.
Great job, Matt. So I asked you a question the last time we did this, and it was, in your experience, are enterprises leveraging the benefits of QoS? If not, why? Can you give us a little bit deeper dive on that?
Well, I think in general, some organizations probably think they don't need it or they don't realize they need it. My suggestion is that every enterprise requires quality of service. So voice and video traffic is absolutely sensitive to delay and packet loss. It's important to track that. The typical argument against quality of service is, well, we don't experience any congestion. We have plenty of bandwidth. The issue is that you add a new application to your environment, that could change very quickly, and now all of a sudden you need to scope out, design, and implement a quality of service configuration. that can be very time consuming, and you also have to have a lot of knowledge around how to put that in place effectively. So I think to answer your question, in general, organizations are probably using quality of service to a certain extent, but probably not to the best ability of what the hardware provides.
Fabulous. Thank you, Matt. You did a great job today. Again, thank you all for attending Straight Talk. Please send your questions, feedback, or request a deeper dive at straighttalkqa.ciscomtechnologies.com, or ping your account team to set that up. We do these sessions every month. We try to bring new content on a monthly basis. You can go to our pre-recorded or recorded seminars out on Cisco Technologies and Straight Talk and request access to those as well. Have a great day and look forward to having you on these webinars moving forward. Thank you.